One is fundamentals. It's reviewing topics that were explored in your first year chemistry class. The first topic we're going to take a look at is Sig Figs as well as scientific notation. So Sig Figs, just as a reminder, all the digits that can be determined from a measuring device along with an uncertain digit, an estimated digit. All of your non-zero digits will always count as significant figures. If you write down a number from 1 through 9, you wrote it down because it was part of your measurement. Sometimes you will have very small measurements. You'll have what are called leading zeros, zeros that come before your first non-zero digit. They would not count as significant figures. So in that first example with the non-zero digits, 4.35 grams would have 3 sig figs, while 0.015 would only start with sig figs at the 1, it would have 2 sig figs, because you could write that in scientific notation form as 1.5 times 10 to the negative second and still show the significance of the 1 and the 5, as well as the size of the number with the exponent. Remember, scientific notation is just a way to write really big numbers, really small numbers. If your number is large, you're going to have a positive exponent. If your number is small, you're going to have a negative exponent if it's less than 1. Sometimes when you are looking at measurements, you will have captive zeros, zeros that fall in between non-zero digits. Sometimes they can fall together, as in the example there, 40.05 seconds. Sometimes there might be non-zero digits that fall between zeros. Sometimes there might just be a zero. And it doesn't matter whether there's a decimal or not, or where the decimal is at. As long as you have non-zero digits surrounding your captive zeros, the zeros that are stuck in between would count as significant figures. If you had $40.05 in your bank account, you don't want those zeros to fall out. You don't want your bank account to drop to 45 cents. And then finally, we have trailing zeros. Those are the zeros that are found at the very end of a measurement. That measurement may have a decimal and may not. They will come after your last non-zero digit in your measurement. If there is a decimal reported for that particular measurement, and there are trailing zeros in that measurement, those trailing zeros will count as significant figures. So in 30.0, the only non-zero digit is the 3. The 2 zeros that follow it would be considered trailing zeros. And because there's a decimal, we're saying that we were able to measure exactly to 30 and that we estimated that the tenths place was a 0. So that particular measurement would have 3 sig figs. While 30 moles without the decimal is an approximate value. The last digit we were able to determine was the 3. So only the 3 would count as sig figs. And if we were going to write that number in scientific notation form, it would just be 3 times 10 to the first to represent the same number of sig figs as we saw in our original measurement. With 30.0, we would write it as 3.00 times 10 to the first to represent the 3 sig figs that are present in 30.0 amperes. Something I did not mention in this PowerPoint, but I do want to touch on, are exact numbers. Remember that significant figures only apply to something that you can measure, while exact numbers are not ones that require a measuring device. They're ones you can count, or they're ones that are defined, like 60 seconds and a minute. Those do not have sig figs. They are considered to have unlimited number of significant figures, and they should never impact on your calculations with significant figures. When we are looking at adding and subtracting, we want to look at each of our measurements and find the one that has the least amount of precision in terms of its decimal places. Sometimes it might fall before the decimal place, but more often than not, there's going to be either no decimal places or one or more decimal places in your different measurements. We can assume more precision than our measurement that is the least precise, the one that gives us the least amount of information. So we have to report our answer to the same number of decimal places as that measurement that gives us the least amount of information. When you multiply and divide, you don't have to line things up by their decimal places where you do in adding and subtracting. So we don't look at decimal places with multiplication and division, we look at significant figures. Whichever one of our measurements has the least amount of significant figures, that's what we're going to report our final answer to. If you have multiple multiplication division calculations to do at the same time, or multiple addition subtraction calculations to do at the same time, you would do them all and then do your rounding. If you happen to have a calculation that involves both rules, you're going to follow PEMDAS. You're going to do your order of operations. And if that means you need to add and subtract before you can multiply or divide, then you would do the addition subtraction sig fig rule, and then you would apply the multiplication division sig fig rule. And you would do the opposite if that was the case. So if you have both types of calculations occurring, make sure you pay attention to which one you need to do first. So here we've got some answers, examples for you to do. We're going to multiply those two numbers together on your calculator. Remember, you can put that times 10 to the negative second in with the exponent button or by using your caret. 2.03 has a captive 0, so that number has 3 significant figures. 4.1 times 10 to the negative second, the exponent does not impact on your sig figs. If there are 2 digits before the times sign in notation form, means we want 2 sig figs in our answer. And so when you put that into your calculator, let's see, that's what I got rounded, but I do want to check and see what the calculator gave me. So 2.03 times 4.1 to the negative second squared. I got 0.00341243. Because I wanted 2 significant figures, since it was a multiplication division problem, remember those leading zeros do not account for sig figs. So although I need them as placeholders, my first sig fig is the 3, my second one is the 4, and the 1 would not round them up. So that's why I left it at 0.0034. And if I was asked to report it in notation form, because that number is smaller than 1, I always want to move the decimal so that one non-zero digit is in front of the decimal, and that would give me 3.4 times 10 to the negative third. In my second example, I'm taking two numbers in exponential form, 2.4183 times 10 to the second, meters, and I'm going to multiply it by 3.05 times 10 to the fourth. Again, both of these are in scientific notation form, so I want to look at how many digits come before the times sign, since all of those are being represented as sig figs. 2.4183 has 5 digits before the times sign, so 5 significant figures. 3.05 has 3 digits before the times sign, or 3 sig figs. So when I round my answer to 3 significant figures, the calculator gave me a value of 7375815. All of them are non-zero digits, and I only want the first 3 since this is multiplication and I'm using my sig fig rule. So I'm going to keep the 7, the 3, and the 7. The 5 would round the 7 up to an 8. And to keep the number the same relative size, I would need to add on zeros as placeholders. I would need to add on 4 of them because the 7, 3, and the 8 had 4 other digits after the rest of that number. With the units, because I'm multiplying, I would multiply the units together just like you would in math class. X times x would be x squared, which is how we get meters squared. In notation form, if I want 3 significant figures, I'm going to move the decimal over between the 7 and the 3. I had to move it 6 places, and to show 3 sig figs, I would just write it as 7.38. The final example is going to be one that involves using both your addition subtraction rules as well as your multiplication division rules. We have to subtract before we can divide. So when we take 508 minus 200 seconds, we get 308 seconds. Because neither of those had any digits past the decimal, we're going to keep the 3, 0, and the 8. So it does have 3 sig figs, but not because of the type of calculation you're doing. You're looking at decimal places because of the addition subtraction rule that is occurring. We're going to take 308 and divide it by 200. Both of those are now going to follow the multiplication division sig fig rule and have 3 sig figs, and we get 1.54. When we subtracted seconds from seconds, you're left with seconds. And when you divide by seconds, the seconds cancel out. So this is now going to be a unitless number. I got 1.54. And then it asked me to take that and multiply it by 100. I wanted 3 sig figs in the calculation where I divided 308 by 200 because both of those values with the decimal after the zeros had 3 sig figs. The 100 is not going to impact on my sig figs because I've told you it is an exact value, that it has an unlimited number of sig figs. So when I multiply this by 100, and we often do this in percent calculations, I got 154.